Thank you for the introduction and for the invitation to come and give you a flavor of the work that we do at CDC. As a disclosure, all the work I'm going to be presenting today has been supported by CDC, so by everyone in this room. And I'm going to be talking not as much about diet, but as about components of the diet and chemicals that are present in everything we do in our daily lives. We are exposed to chemicals in the food that we eat, in the water that we drink, the air that we breathe, and in all the activities that we conduct on a daily basis. However, the human exposure scenario is rather complicated. We do not have the luxury of like controlled conditions like those that in many cases exist in toxicology, in traditional toxicology and animal studies. We actually are exposed to a rather vast number of chemicals and many different exposures and many sources and routes. Also is interesting that we certainly are very much unaware of the dose of those exposures, their duration, and their timing. So maybe we were exposed in the morning or in the afternoon or yesterday and not today. And somebody touched upon this topic with a slightly different aspect earlier today, and is that we are really not exposed to one chemical, but we are exposed to really a suite of chemicals, a cocktail of chemicals, mixtures of multiple chemicals. So in this rather complicated scenario, how can we assess exposures? And the answer to the question, obviously, is that then one size doesn't fit all. So you have different approaches that you could use for assessing exposure to environmental chemicals. Traditional or epidemiology has been using questionnaire information or historical information. People have also used in the past environmental monitoring, so looking at the chemicals in the media, air, water, in the food, soil, and so on. And also personal monitoring. There is extensive use or proposed use lately of using hand wipes. Also for some chemicals, particularly those that are in the air that we breathe, with personal sampling. And the last approach, and the one that is dearest to my heart, is biomonitoring. And is only one of the tools for assessing exposure. And really, the best combination to assess exposure would be just combining the data, the information that you gather from these different approaches, and then construct models that then you can just determine exposure. Biomonitoring is actually pretty much just looking at the chemical rather than outside, the chemical that is in the body. So we look at the chemicals. We actually measure chemicals that are in the metabolites or the parent compounds that are present in human samples. And in general, we use for our biomonitoring efforts mostly our blood and urine. So we look at the chemicals that are either circulating in the body or the chemicals as they are excreted. It's very important to remember that biomonitoring is going to integrate all potential sources and routes of exposure. So when you get the concentration of a particular chemical, chemical X, in the urine, then it's going to come from everything that happened before that, the different exposures that took place that resulted in that chemical eventually being absorbed and then metabolized and excreted. And there's no way from that measurement that you're going to be able to say is the chemical came from exposure 1, 2, or 3. So again, it's going to integrate all the different sources and routes of exposure. And we're also going to be measuring concentrations at trace levels, much lower concentrations than the concentrations of the chemicals in the environment. And this goes into biomonitoring, the aspect of biomonitoring that is the reliance on analytical chemistry, and the fact that we tend to use expensive instrumentation, so in short, biomonitoring is expensive. And please do remember also that we measure concentrations. We actually do not measure exposures, but we use those concentrations then to quantify exposures. At CDC, we use biomonitoring for plethora of different programs, but I'm just going to give you, and I'm going to spend most of the time today, actually particularly all of the time, just talking about the large-scale surveys. And you have heard about NHANES, the National Health and Nutrition Examination Survey. So this is our bread and butter, and I'm going to give you a slightly different view of what NHANES also provides. There are other surveys as well, but NHANES is really the one that we work on the most. We also work mainly in collaboration with epidemiologists and other health scientists on studying specific populations, because NHANES, as several people have already pointed before, out as a national survey. And sometimes we may be interested in evaluating exposures in a certain group of the population, particularly those that are more susceptible or vulnerable to the potential adverse health effects from exposures. And those are like, in general, we tend to think of those in pregnant women, children, and the elderly, and also in some cases minority populations. And sometimes we may be interested in looking at the highly exposed populations, and those, in some cases, you may find them in occupational settings. We also do apply biomonitoring in emergency investigations and disease clusters, although I won't be talking about those at all today. So, NHANES, the National Health and Nutrition Examination Survey, since 1999, is an annual survey that is administered by the National Center for Health Statistics, which is one of the centers within CDC. NHANES is conducted through US Congress funding, so as I said, taxpayer money are supporting the work that we do. And NHANES is mainly a survey that is designed to just obtain clinical and nutritional data. That's why we heard before about those dietary recalls and then, the recall questionnaire and all information and clinical parameters. In fact, NHANES data are being used for then when parents take their children to the doctor, to the pediatrician, and they talk about those growth charts. So NHANES data are the ones that have been used to get those growth charts. I was told that also retailers use NHANES data to figure out the sizing that they have to have for clothes. So, that would fit most of, or everyone in the States. NHANES is actually a complex survey. After all, is administered by our colleagues, the statisticians at NCHS, and is a very complex survey that of the civilian, non-institutionalized US population. And what is interesting is that NHANES goes to about 15 different localities in this MEC, the mobile examination centers. They go every year to about 15 different places in the United States and recruit about 5,000 people. And then the results of the NHANES are reported in 2-year cycles. So 1999, 2000, right now we are in 2015, 2016. NHANES, the participants in NHANES, in these mobile examination units, they undergo physical examinations, and then they provide medical history, they provide some demographic information, socioeconomic and behavioral data, and for the purposes of what we do in my part of CDC is that NHANES also collect biological specimens. Most of them are used for clinical chemistry usage, so the participants actually get a physical examination, so they will get some information about, their cholesterol, their, you name it, blood count, and so on. And, but some of these specimens, we also use them for nutritional, for the performance of or evaluating exposure to nutritional biomarkers and environmental chemicals. It's important to realize that we have a limited amount of blood and of urine per each participant in NHANES. And here I was trying to indicate that, I don't know, you can hear me, that for people who are children 1 to 2 years of age, only 9 bloods of blood are collected and no urine at all. As you grow up, then or you get older, then we're able to collect much more blood. So in this means that we're only going to be able to measure many chemicals that are found in blood only in people who are 12 years of age and older. Although for the chemicals for which there is evidence that they could be they could result in adverse health effects early in life, then we try to measure those in everyone. So we measure blood cadmium and mercury in every person 1 year of age and older, and cotinine, which is a marker of environmental tobacco smoking, every person 3 years of age and older. Some nutrition markers are also measured in the very young. In terms of the non-persistent chemicals, the chemicals that come in and out, that they metabolize very quickly, and we measure those in urine, the urine is collecting everybody who's 6 years of age and older. And starting in 2015, so with this current cycle, we are also now collecting samples from children who are 3 years, between 3 and 5. And then, as I said, we recruit about 10,000 participants every 2 years, but we do not measure the chemicals in every participant, but in what we call 1/3 subsets in general. So these are randomly selected subsets of participants that then they maintain the representativeness of NHANES, so they're also representative of the US population, but in general, we measure all these different chemicals in about 2,500 people. And with this data, what we do is we have what we call the national reports. One of the reports is the report on biochemical indicators of diet and nutrition that we do it to improve the laboratory diagnosis and detection of the nutrition-related diseases. And we had so far 2 of those reports. Released in 2008 and one released in 2012. Overall, they provide information about 58 biochemical indicators, and then going within, distributing among the trace metals, different types of vitamins, isoflavones and lignans, and acrylamide. And the part that I'm the most familiar with is on the national reports on human exposure to environmental chemicals. This is the most comprehensive biomonitoring assessment of the US population exposure to various classes of chemicals, including metals, persistent organic pollutants, and non-persistent chemicals. We release this data, and now is about yearly or so on the on our website, and it's at the National Center for Environmental Health, where I work, which is one of the other centers of CDC. And these reports are used to set reference ranges, to track temporal trends, monitor interventions, to assist with some priorities, and assist also with exposure and risk assessment. And I'm going to give you just a few examples of each one of those characteristics. The exposure reports do not have really much of data interpretation. We provide tables, and the tables for the different chemicals, and we do not have a health outcome analysis. And with the caveat that we have written pretty much everywhere around the website, that the presence of a chemical in the body really doesn't mean that it will cause disease. We cannot identify levels that may cause disease. For those, then you would need additional studies. And NHANES also, per design, does not provide geographical information, not at the local, state, or regional level, or seasonal data. And this is to protect the privacy of the NHANES participants. As I said, NHANES, the MECs, the units go to 15 localities within the United States. So it could be possible that if someone had very unique demographic characteristics, and maybe when the MEC had gone into that area, that you could identify the person. So NCHS will not release this data publicly. They also, NHANES does not target populations that would have potentially high or low exposures. Is a survey that is designed to look at the general population as a whole. And then if we are interested in looking at these exposures, then we would do it in collaboration with investigators, and then in other, for example, looking in a state, when one particular state is interested in just learning about the specifics, exposures in that particular state, they can have certain efforts just targeted for the state, like Biomonitoring California is one of the largest one, and current now, or the New York City HANES that was conducted a few years ago. And also, as I said, because of the way that the samples are collected, we have limited blood from the very young, and then we have no urine at all from children until they are 3 years of age. Then we have limited information for the very young. So here are going to be a few examples on how biomonitoring can be used for the purposes I described before, who is exposed and how much. So this is an example of Triclosan. This graph represents exposure or concentrations of Triclosan in NHANES. In NHANES, these are data from NHANES 2003-2004, but then using the NHANES data, and I don't have to go down, NHANES data, and the information about the household income, what we found was that increasing in the concentrations of Triclosan, this is an antibacterial agent that is used in many antibacterial soaps, in antibacterial dishwashing liquids, in certain toothpaste, then the concentrations of this antibacterial were increasing with household income, which is kind of intuitive because those products tend to be more expensive, and also people with a higher SES tend to be more concerned about exposure to chemicals. So the fact that, we're seeing higher concentrations in the more affluent is not really that weird to me. This is an example that I like to show because, again, it kind of to show that biomonitoring does give you information that make quite a bit of sense, and sometimes that but you didn't have scientific data to prove. This is on sunscreen exposure, so it's not really that much of a dietary component, although some people tend to just put chapstick or something and then just eat it all the time. But anyway, looking at the data, what was interesting in this study that was women tend to have higher concentrations of the sunscreen agent in their bodies than males. And it was higher in non-Hispanic whites compared to blacks or Mexican Americans, which kind of makes sense. People with lighter skin are going to use more the sunscreen agent. And this was also true in case of at the 95th percentile, so in the people at higher exposures. And in this graph here, then we also divided, or when we did the adjusted models, then it turned out that there was some influence of age and with the race in the concentrations of the chemical. And I would like for you to look at the kind of tan bars that those are the non-Hispanic whites. And then you can see concentrations that fall kind of a weird pattern. So the way I can explain this pattern, and again, this is my interpretation, I think makes sense, but you'll be the judge, is like we see higher concentrations in young kids because you want to protect them from exposure to sun. So you're going to make sure that your child is going to be very protected. Concentrations are going to start going down, and adolescents have lower concentrations than their younger peers because they want to be tan. It looks good, and then some of them even go and get tan, and they don't want to have sunscreen agent. I remember running after my kids when they were that age, and that was the last thing I could do, and it's very embarrassing. You're in your 20s, and then you realize that the sun damage can be pretty bad, so you start putting sunscreen agent. When you're in your 30s, you don't have time to put sunscreen agent because you're running after your children who are young and you want to protect. In your 40s, you say, oh my God, I have all these wrinkles, I need to do something about it. You start using sunscreen agent again. And then when you're in your 50s, the damage is all done. It's too late then. Forget it. There's no point in spending money on the sunscreen agent. So anyway, this is my interpretation, but I just think it makes kinds of sense, and then it just to show that the power of biomonitoring. In other instances, biomonitoring also can show us exposure trends. And this is an example looking at surfactants. Fluorochemical surfactants that have been used since the 50s in many different type of applications, and actually quite a bit of exposure is probably dietary to these compounds. But these compounds, because of their properties, they were persistent, some of them bioaccumulative and toxic, then they were phased out from commerce, actually in the early 2000s. So you can see like the precursor of PFOS, one of these compounds, peaked around the 1990s, and then production started decreasing. And then what is kind of interesting is if you look at the enhanced data, and we have data since 1999-2000, so since before the phase out, so you can see how concentrations have been going down. Actually, the concentrations of PFOS in the blood of Americans have decreased by almost 80% from 1999 to 2011, 2012, suggesting that once the compound was taken out of commerce, then the exposures decreased. We continue to measure PFOS. One could say, why are you doing it? The concentrations are going down. Well, these compounds are still being manufactured in China, and because of their properties, they can move from one part of the globe to another. Actually, these compounds have been detected in polar bears that did not have much to do with the use of the chemicals. Then that's why we continue to measure them. We also like to show that you can see trends that in concentrations that are going up in one case for certain chemicals or going down. And this is an example showing a decrease in concentration of a metabolite of organophosphate insecticides that were discontinued from residential use in the early 2000s, and the concomitant increase in the concentrations of another type of insecticides, the synthetic pyrethroids that have been used that are being introduced to replace the organophosphates. And this is an example that with what's happening now with Flint, it just kind of brings attention to the importance of, for certain chemicals, knowing the levels in people. We can use also biomonitoring data to set the prevalence about certain thresholds. And this is for lead blood levels, which are higher than 5 micrograms per deciliter. CDC set this value in October 2012 using the 97.5th percentile of blood lead distribution in children 1 to 5 years old of enhanced. And CDC is going to be keeping on updating this reference value every 4 years using the 2 most recent enhanced data sets. So we are in the 4th year, so this could be the new value may just be coming next year. So what do enhanced biomonitoring data show? They show widespread exposure to certain chemicals that are, as I mentioned before, they're coming from multiple sources and pathways of exposure, and there may be differences in the prevalence and the magnitude of exposure to these chemicals among the various demographic groups between children, adolescents, and adults, by sex, race, and socioeconomic status that may be driven by lifestyle, obviously. It could also be by that lifestyle that is going to impact the exposures, although in some cases one could say that maybe genetics could take some part. And enhanced also are very good at showing exposure trends. One of the things with enhanced that I won't have much time to talk about, but somebody already mentioned with the dietary recalls, is that for some chemicals that are short-lived in the body and exposures tend to be episodic, then concentrations are going to be up and down based on when the exposure happened, when the sample was collected after the exposure, and on the nature of the population too. So this is an example that shows concentrations of one chemical that is used in personal care products, and one chemical that is, these are phthalates, that is the main route of exposure to the parent compound is use of personal care products. Here is diet. But what you can see, this was a study we did a few years ago with 8 very dedicated CDC employees that provided every single urine sample during a week. And concentrations were going up and down, and the changes were really dependent on where the exposure was coming from. If it was a chemical that you use in personal care products, you either use it or don't use it. So the difference were between person, rather than if it was diet, then you eat every day, but every day you may eat something very different. So the differences are going to be most within a person. So can we really use one sample to assess exposure? Because in enhanced, again, is only one sample. And this is, I apologize if you cannot see it very well, this is just showing the urinary concentrations, the ranges of concentrations between 2005 and 2006 for almost 1,100 adults. And then of bisphenol A, this is a chemical that is used in many different applications, but for which exposure tends to be dietary. And this is the range of concentrations in these 8 same CDC employees I mentioned before, and within a week. And what is remarkable is that despite the variability that I showed you before, the range of concentrations in enhanced during 2 years, and the range of concentrations in these 8 employees during 1 week is remarkably similar, suggesting that yes, indeed, probably one sample is good enough to assess, categorize like an average population exposure. And when you have 2,500 people, it may be, you can say, okay, this is good. But what if you have a smaller population? And this is an example that was an intervention study looking at 75 Harvard students that consumed for 1 week fresh soup or then canned soup. And the result of the study showing that when you were consuming the canned soup, because BPA may be the coating of the cans, then the concentrations in these people were much higher than concentrations that we have seen in the general US population. So when exposure is the driving force, you may be able to get even one sample is good to assess exposure. So to conclude, the take-home messages, biomonitoring is one of the tools for assessing exposure. Interpreting biomonitoring data is, and I didn't go into this in the presentation, but certainly is much more than a laboratory measurement, and in some cases you may need multiple samplings, particularly for these non-persistent chemicals. If you use properly, you use it properly, biomonitoring will certainly improve the exposure assessment. And in terms of ENHANCE provide excellent information about the exposure of the US population to a certain number of chemicals. We can combine the biomonitoring data with the clinical and nutritional ENHANCE data to see whether we can find certain associations, including some with health effects. But ENHANCE per design cannot answer all the public health issues. But we have been using ENHANCE and plan to use it for supporting public health guidelines. I want to thank my colleagues at the Division of Laboratory Science, most of us chemists, who are generating the data, the National Center for Health Statistics, and all our collaborators, and thanking you all for your attention.